In this video, we will discuss why the Redis database is the great choice for storing gaming leaderboard results. We will also learn how to compute leaderboard from the enriched data stream and save it and update it in real time as the data arrives at speed. Welcome to part 3 of the video series in which we are building a real-time gaming leaderboard application using Apache Flink. Over the course of 5 episodes, you will learn all parts of streaming architecture starting from ingestion, enrichment and all the way to visualization. You will also learn advanced analytics technique like control channels for A/B testing, handling late arrival of data exactly once, archival and on-demand replay of the data. In the last video, we extended the architecture and implemented streaming enrichment using database CDC. By the end of this video, you will have learned how to compute the leaderboard by processing enriched data, store results in Redis and visualize the leaderboard on Grafana. As always, GitHub repo can be found in the description below. Let's get right into it. So let's understand what is Redis. Redis is an in-memory database which can hold the keys and values, and it is very widely used across the industry for caching purpose, and whenever you can imagine there is a requirement for loading the data and retrieving it at speed. Therefore, it is very widely applicable in the real-time analytics world. For the real-time analytics use case like ours, it is much more relevant because we could leverage the Redis data structure called sorted set which is capable of automatically resorting the events as we ingest. So, let us understand first operation which is ZINCRBY. Imagine you have a query sent to the Redis which says ZINCRBY player 3 and 50, and you already have this sort of key value against the player name and the total distance stored in Redis. What will happen in Redis is exactly this. As soon as this ZINCRBY 50 operation gets executed in Redis, it does two things for us. First, it increases the total distance by 50 and it propagates this effect in terms of the reorganizing the leaderboard and resorts it. That is where you see player 6 has moved now to the second position and player 3 has come to the first. Let us understand another operation which is ZADD. What happens when you fire a query to Redis called ZADD GT player 11 200. In this case, imagine Redis already has a leaderboard of a player with the speed. This time when you fire up this query for player 11, top speed has changed from 100 to 200. So, again same thing happens, Redis updates the speed from 100 to 200 and automatically propagates, reorganizes the data, and now you see the new leaderboard with player 11 taking up the lead position. But because we use GT operation within this query, what happens when we let us say update with the speed 180. In this case 180 is less than 200, which is basically a no op for Redis, and Redis does not update or does not even execute the query given that the data which is stored within Redis is already higher than this. When it comes to AWS to host the Redis database, you have two options. First one is the Elastic Cache and second one is Amazon MemoryDB for Redis. What is the difference? Elastic Cache keeps the data in memory, whereas MemoryDB is persisted in nature. So, whenever you have persistence as a strong requirement, you can go for MemoryDB. In the leaderboard use case, we will be using Amazon MemoryDB. What we have built so far is architecture like this, where we connected the database and we have the enriched stream. Now, we will add a new Kinesis data stream which is used to populate these queries, backed by the Lambda which reads this query and simply executes on Redis and then finally visualize it in Grafana. So, as you see in the source code, now as a part of a part 2, we already created the networking and the notebook. Now, in the part 3, we will create a new stream called results stream, which is nothing but a Kinesis data stream, and then a new construct called MemoryDB sync, which is just a mix of two things. First, the MemoryDB for Redis, and the second, the function which is responsible for syncing the commands that you push to the results table into the MemoryDB for Redis. Next, you have the Grafana. When you open the Grafana, there are two portions. First is the secret, which contains the username and the password to log into Grafana, and second is the EC2 instance hosting the Grafana server. You can also use manage Grafana if you wish to, but just for the simplicity I am using the Grafana hosted on EC2. Now let us go to the GitHub repo. As usual, take a checkout of branch 3 called process store visualize setup. As you see in my terminal, I am already in that branch. Go to the infra folder and hit CDK deploy. Again, it will show you all the changes that will be deployed. So, to accept the change, say yes. If you have any questions about anything or the pieces of the architecture, please leave comments and I will reply to it. Now let us wait for CDK deploy to finish its deployment. So now the deployment has complete. What you will see in the output section is the new parameters appearing. So first one is the credentials for login to Grafana. It's basically a link to secret manager, and second is the Grafana server URL, which you can click to open Grafana. Again, let's go to the Kinesis Analytics service and the Studio Notebook. You will see a new Studio Notebook appearing, which ends with InVPC. So let's select this notebook and hit run to start. We can also stop the other notebook. Just make sure to download the notebooks that you have already created to preserve your work. In any case, you can always stop and start notebooks again. Now that our notebook is running, let's open the Zeppelin. You can import the notebook by selecting the import. You can import either from the repository or the one you saved as a backup. Okay, so let's go through all the challenges answers one by one. To create the player table, you go to the stack, go to the output section, open the link which takes you to the MySQL credential in a new tab, which is a secret manager. Then you open the retrieve secret, copy the password, paste the password in password section. Let's take the host name as well from the CloudFormation output, which is here, copy it and paste it here. Now let us run this paragraph which will create the player table for us. Challenge was to select the data from players table. It is as easy as select star from players. When you run it, you can see the data for player like this. Next, you can use the describe table to see the schema for the table, both of them. Next, challenge was, can you select the data for player table and plot it as a pie chart. So the query here looks like select country count distinct player ID as player count from players group by country, and let's run it. Once this query runs, you can select the pie chart as a visual option in the output, and soon you will see the pie chart with the distribution of live players by country. There you go. Just make sure to pause the query after it successfully runs, because it is important to pause the query. Only one query can be run at a time. Next one is about the join. So we will join the event table with the player ID. You can use the syntax like for system time as event time zone, just use the time zone 1 based on the player ID. Once you join the data, what you will see in the output is both the table joined by the system time And that brings us to the challenge for part 3. You can start with that join query, you place it in the with clause and then you select whatever aggregation we need to. Essentially you select 2 aggregation, first one for the average speed, second one for the total distance. You can place your aggregation here. Next one, register that as a view and then create the result table. Result table is as normal as other tables, just make sure the region is correct. I have already provided you 2 queries about ZINCRBY and ZADD commands. You can use this query to insert the data into MemoryDB or generate the queries for inserting into results table. Challenge for you is, can you insert the output, which is the query, into results table, which is as easy as insert into, of course, result table and whatever you select. So, what we started is with the ingestion portion of the architecture, which looks like this. Then we evolved it to the second part of the architecture by adding the database, and then finally we are doing the third part, which adds essentially 2 more components. One is the Lambda function, copying the data from results table into Redis. So, let us take a look at the Lambda function more in detail. The source code for all the Lambda function is stored in this functions folder under the infra. We are interested in Redis sync function, so let us open it. So, what function does? It is really just 4 lines of code. First one, it reads the record from Kinesis data stream, decodes it and then reads the command, which is the Redis query from the Kinesis record, splits the query to convert into a proper Redis command and executes it over the Redis. Once you run the query on the notebook, you can click on the Flink UI, which loads up the Flink dashboard just like this. You can see the records moving across the stages. If you manage to do the insertion right, you will see the records flowing at the last part. Now, you go to the Grafana URL to retrieve the secret, copy the password and log into the Grafana with Grafana URL, which I have already opened and logged in. In your case, you can log in with the password, go to the Redis in connection section and hit create Redis connector. Now, again going back to the CloudFormation, you can copy the Redis connection URL from the output section and paste it into the address column. Next, you hit save and test and you will see if the connectivity is successful. Next one, click build dashboard and add visualization. Select the Redis source. In the type, you can select Redis and the command will be ZADD range. Basically, a ZADD range command selects whatever you have in the sorted set stored in the Redis. For the keys, you can use the key called leaderboard colon top underscore speed, which is the key you used in the Flink query, or if you want to select total distance, you leave the leaderboard as it is and say leaderboard colon total distance. In the range query, you select index range and 0 to 10, which basically brings top 10 players on the graph. You hit the switch to table to see the output as a table. As you see, it is not nice right now, it is horizontal, but I will show you how to convert that into vertical one. So, you go to the transform, select reduce, deselect max and select total, and as you see now the table is in the vertical format, but still we need to sort it. So, you select the sort as a transform and you sort based on the table, but you do the reverse sorting and there you go. So, now you have a leaderboard sorted based on the total distance max to min. Similarly, you can create the same dashboard for top speed. Today, we learn how to compute leaderboard and store the results into Amazon MemoryDB for Redis. As you saw, Redis data structure store sorted set helps us automatically adjust the ranks by processing new events. If you enjoyed this video, please give it a like. In the next video, we will see how you can use the control channel method to update parameters, introduce feature switches and change the filter condition without downtime or restarting application. See you there.